we are supposed to consider this particular summation over here. And if you were to go back to the question and look at part 2, we have this, which means that if I were to bring this over to the left hand side, we have a un minus 1. It is equal to n to the power of 3 plus n, which means that this can actually be re-expressed ur minus 1, replacing n by r. We have a summation from r is equal to 1 to n of r to the power of 3 plus r. And we can still simplify this further by factorizing out r, and that will give me a r multiplied by r squared plus 1, which is actually this summation over here. So on the right hand side, this, according to part 1 of the question, is going to be 1 over 4 n plus 1 and n squared plus n plus 2. And as for the left hand side, I'm going to try to execute a method of difference by expanding this into its summation format. When r is equal to 1, it is u1 minus away u0. Then when r is equal to 2, it is u2 minus away u1. When r is equal to 3, I have a u3 minus away u2. So I can see this as the pattern of my cancellation. 2 rows giving me 1 cancellation, so I'm going to write 2 more rows in the back portion here. And when I let r be equal to n minus 1, I have a un minus 1 minus un minus 1 minus 1 will be un minus 2. And finally, when r is equal to n, we have a un minus un minus 1. And we see this same pattern of cancellation here, so we can be pretty sure that in between they will all be cancelled off according to this pattern. So on the left hand side now, I'll be left with un minus away u0, and on the right hand side it is 1/4 n plus 1, n squared plus n plus 2, which means that un is going to be equal to u0 plus 1/4 n plus 1, n squared plus n plus 2. And what is u0? From part 2 of the question, we know that u0 is 2. So it is 2 plus 1/4 n plus 1, and n squared plus n plus 2.